Very good evening, everyone. Hope you all doing well. So today we are here with Google Developer Group Sri Lanka Cloud Tech Talks June edition. So we hope you all enjoyed this evening's stroll to expand your knowledge of your favorite areas of AI technology. So without further ado, let's get started. Today you can discover how to build, deploy, and scale machine learning models using Vertex AI. So Suresh, who is a co-founder of InfoBase, a GDG organizer and a cloud researcher. Suresh, the stage is yours.
Hi, thank you very much. So today we are going to talk about the latest Google Vertex AI, which is known as the Google's AI platform. So without further delay, let's get started. So with my introduction, I think so I already did a small introduction. So I'm Suresh Peris, and I'm a GDG organizer as well as I'm the co-founder of InfoBase. So let's get started. So for the topics for the today is basically we are going to talk about the introduction to Vertex AI, and we are going to talk about what are the data sets available on Vertex AI and how we can manage different data sets that are available. And we are going to talk about how we can manage multiple notebooks and like workbooks kind of thing. Basically, when managing IPython and data science projects. So we are going to talk about the notebooks, and we're going to talk about the training of ML models as well. And we're going to talk about two approaches that we're going to take, basically the AutoML approach and the custom ML approach. And we are going to talk about how we can deploy ML models as well as we're going to talk about explainable AI. And finally, we are going to do a code lab and small demonstration for you all to get to know about how the platform works and a small demonstration. So yeah, so let's get started. So what is Vertex AI? Basically, in brief, I would say in brief, Vertex AI is a Google's all-in-one managed AI platform. So early it was mainly called the Google AI platform. So in recent years, like it has become a fully integrated platform that you can do multiple AI related tasks in one place. So Vertex AI is a unified AI platform that brings together all the Google's machine learning services under one roof. So you can easily build machine learning models, deploy them, and scale them with Vertex AI's pre-train and custom tooling. Also, you can use AutoML and other advanced ML components to greatly improve productivity and scalability when developing ML solutions on the cloud. So talking more about Vertex AI, it's actually designed to be a user-friendly platform for beginners, as well as it's going to be a time-saving solution for experts as well, because we are going to have multiple low-code tools as well. So because of that, it's going to be a time-saving solution for experts as well. Yeah, so that's why it's actually simple to train models and uses 80% of fewer lines of code when compared to the existing ML training solutions. So, so basically, talking more about Vertex AI, it provides unified definitions and implementations of four concepts. So, which can be known as data sets, which can be known as the training pipelines, and we can have custom and auto ML models, and finally, we can have different types of endpoints when we are running workloads and ML training datasets. So let's go to the next slide. Yeah. So Vertex AI has different types of training mechanisms, and we can have. I think if you all have heard about AutoML, you all might have a small idea about what it does, and not just AutoML. So Vertex AI supports complex custom-built machine learning models as well. So Google's AutoML platform allows developers with little or no machine learning knowledge to train high-quality models tailored to their needs. So it's part of the Vertex AI ML platform, and it helps you train models on GUIs, basically the graphical user interface, or you can use your own IDs when you're developing the ML models. So let's talk more about that in the further slides. This is just a small introduction about what it does in a nutshell. Let's have a look at a small video. I think you will be able to get a small understanding about about what is AutoML and what the main purposes of AutoML. Let's have a look at the video first. Sorry, there was a small technical difficulty. Let me stop the screen once again and let me put the audio. Give me a second.
Make AI technology for image analysis easily accessible for enterprises, so we created Cloud AutoML Vision. Currently, to perform image analysis on Google Cloud Platform, developers can use the Vision API to access a pre-trained model or design and train a custom model with Cloud Machine Learning Engine. Let's say you're a meteorologist and want to train a model to identify different types of clouds, like cumulus, cumulonimbus, or stratus, to predict upcoming weather patterns or flight plans by different. If you tried this with the Vision API, here are the labels you'd get back. It wasn't trained specifically to identify different types of clouds. What if you want to train a model to classify images specific to your dataset without writing model code? Cloud AutoML Vision lets businesses and developers with limited machine learning expertise train custom vision models for their own use cases. Developers can upload their own labeled or unlabeled dataset, train and manage their models, and use those models directly from the cloud to make predictions. Let's take a look at the AutoML UI. Begin by uploading your images to Cloud AutoML. Let's take a look at the AutoML press the Train button to train a custom model on your image dataset. When training completes, analysis and stats of the model quality are available directly in the AutoML UI. Next, use your model to generate a prediction on new data, either in the UI or with a simple REST API call. This process is easy from start to finish. Simply upload your data, and Cloud AutoML Vision will handle scalably training and serving the high-quality model. You can learn more here.
Yeah, so I think that gave a small introduction about AutoML, and I think you might have a brief understanding on what it does and the main purposes. So back to topic. Let's talk more about the other options that are available when it comes to training. So just now we briefly discussed about AutoML and what it does, and basically the low-code training model that's available on Vertex AI. So now we are going to talk about how we can develop and deploy custom machine learning models and machine learning containers, training containers on Vertex AI. So Vertex AI also allows to build fully custom machine learning models by using any framework such as TensorFlow, PyTorch, Scikit-learn, and much more libraries. So this is one of the benefits that's available in Vertex AI. So basically, we can pretty much do anything related to machine learning in Vertex AI because it actually provides you a containerized environment for training and testing and prediction. So because of these features, pretty much everything is possible, and it gives you all the GPU accesses and pretty much the hardware accelerations are provided. So because of all these features, it makes much more easier to build machine learning models on Vertex AI. So let's have a look at another video on the custom machine learning models on Vertex AI.
Hi everyone, I'm Anushree Vastava, and I'm going to show you how you can use Vertex AI to train and serve a TensorFlow model. Hi everyone, I'm Anushree Vastava, and I'm going to show you how you can use Vertex AI to train and serve a TensorFlow model using code in a custom container. We'll be using a data set of technical specs of automobiles to build a model that can predict the fuel efficiency of late 1970s and early 1980s cars. You can find this data set on Kaggle. We must provide the model with descriptions of several automobiles from that time period. The description includes attributes like cylinders, displacement, horsepower, and weight. We're working mainly in a notebook, so think of this as an interactive web tool where you can combine code, computational output, text, and multimedia resources in a single home. So we've set up a container in here, a portable environment for working with our model. Don't worry, we have all the source code and instructions for you in a Colab to try this out at home. So now that everything's set up in here, let's train the job on the platform. I can go here to the Trainings tab, create new job, I'll name my demo, add a few other settings like our container URL and compute specs, and now it's off to the races. This one actually takes like 10 to 15 minutes to train, so I ran a job ahead of time so we can test it out together. So now that it's trained, we deploy an endpoint and we can now use this back in our notebook. So now for the moment of truth. Let's predict a sample. I've added a cell down here with the sample case. So this is a set of attributes that we described earlier, but they've been normalized, which is why they don't look exactly like, say, a year or the weight of a car. I hit run, and we can see that an automobile with these values would give us approximately 16 miles per gallon. So to make this visual, I can use a lot of ready-to-go functionality to visualize my data down here. Use graphs and charts to share your findings with your friends. We hope we've inspired you to try working with your own data, or to recreate this demo, check out the links provided.
Yeah, so that's all about the custom ML models. I think I'll talk more about that in the further slides. Yeah, so also in addition to all the custom models and the AutoML models, Vertex also provides full end-to-end tools to automate machine learning operation tasks. So basically, this is called MLOps. So basically, Vertex AI has a lot of MLOps tools that you can use to automate your entire machine learning workflow from dataset management, training, testing, deployment, and dataset and the model enhancements. So we can actually automate the entire flow by using the MLOps tools that are provided by Vertex AI. All right, so I'm going to talk about the MLOps workflow. So this is basically the workflow of generating and maintaining machine learning models from data gathering to model management. So when talking about data gathering, you can see there are several tools that are provided. And when it comes to feature engineering, training, testing, and all, so there are multiple tools. Right, I'll just give a nutshell introduction about each tool that is available here. So when talking about data labeling, it's actually a tool where you can feed images and label the images accordingly based on the provided data set. And it actually consumes AutoML feature that's available, and based on all the provided data, the labeling will be done. It uses computer vision as well as you can. There are multiple tools that are provided to manage your data sets. So there are two dataset types called managed datasets, and there are custom datasets as well. And there are multiple experiments, and there are training tools, and there are prediction tools, and there are hybrid ML models and monitoring pipelines. So basically, when talking about the features, basically feature store, Vertex AI feature store allows for large-scale storage sharing and serving of machine learning features. The feature values can be fetched both for training and for online prediction with low latency. And when talking about the experiments, which is given here, So you might have heard about the technology called TensorBoard that allows you to visualize, compare, and share machine learning experiences. So the Vertex AI uses basically the TensorBoard to give you analytics and conduct experiments on the platform itself. So when talking about the hybrid machine learning approaches, so basically it's a method for improving semi-structured and sequential data for expected outputs. So it allows you to conduct hybrid approaches as well, especially when it comes to model ensembling and all. You should be able to perform all these tasks. So especially when talking about the model management workflow, they have feature called a feature called metadata. So metadata is a service that allows you to manage the ML metadata consumed and produced by machine learning workflows throughout the cycle. So you can actually keep track of all the data that is being gone through the cycle, and you can actually feed the metadata section, and it's actually going to be useful when you are doing enhancements to your machine learning models. Also, it provides you notebooks, and there are multiple pipelines available. So I'll talk about these stuff in the coming slides. So yeah, sorry, I forgot to mention one of the most important things in AutoML. In AutoML, there are some of the key features that are given here. For an example, vision, video, language translation, and tables. So these are some of the key features which is given in AutoML that you can use to make automated machine learning models. So I'll talk about that as well. All right, so this is how it works. So if you're building any sort of application or a backend service or a mobile application or a desktop application, this is how it works basically. Vertex AI platform is here. You can do all the trainings, data gathering part, and model deployment, initializations, and all. Everything can be done within the Vertex AI platform. And you can build the trained models in the same platform itself. And you can perform all the MLOps steps that is given in the previous slides, and you can do whatever related to ML and related to trainings and all. So this can be exposed as an endpoint, basically a RESTful endpoint, and that can be consumed by the backend API. So there are two ways that you can consume the Vertex AI endpoint. You can actually make RESTful calls, or you can have Python SDK installed. So if you have the Python SDK installed, also you can directly communicate with the Vertex AI as a hosted endpoint from the backend side. So from the backend, you can actually proxy all the requests that is coming from the Vertex AI platform, and you can modify whatever the requests that you are planning to get and produce. So depending on your backend logic, you can perform all the logic part in this phase. Yeah, so Vertex AI comes with a huge set of tools that are available. So I think I already mentioned about AutoML. So also it provides you deep learning virtual machine images. So that could be such as, if you're working with technologies such as TensorFlow, PyTorch and all, you might have to have your own environment. So that could be a huge hassle when you're making your own ML environment. So that's going to be a huge hassle, right? So these deep learning virtual machine images helps you to build your own ML environment within few clicks. So you don't have to go through a huge process when you are configuring these environments and setting up your ML machine learning environment on the cloud. So it actually addresses all your requirements. So when talking about AI workbenches, I think you all might have already worked with the Google Colab and Jupyter Notebook, Anaconda, and those sort of tools, right? So Google Vertex AI workbench, basically it provides you a dedicated workbench where you can set up your own IPython scripts, and you can do scientific programming on the cloud itself. So basically, it provides you dedicated workbenches on the cloud itself. So when talking about the matching engine, it's more like a similarity matching. It applies for images, centimeter, and NLP, and those sort of areas. So I think I already talked about data labeling part. So basically, image recognition and the computer vision for data labeling, and it also has AI deep learning containers. So if you are into deep learning technologies such as CNN, GANs, Now you can actually look into deep learning containers as well. And it provides you, the special thing about deep learning containers is that it provides you the graphic access. So in most of the ML providers, they don't offer the dedicated hardware access, but in Vertex here, you get access to dedicated GPUs, and you can customize your own container, on ML training containers on Vertex AI. So talking about explainable AI, it's actually a essential tool when you're developing machine learning models for enhancements. So it provides you explainable AI as well. So I'll talk about these in further slides. So feature store, I think I already talked about this, and these are the other features that are mainly available. So that's it. That's in a nutshell. Well, so let's talk about how the ML workflow works on the Vertex AI. So as I mentioned, there are several stages in the MLOps lifecycle. So I have just extracted four phases. That is data gathering, development, training, and deployment. So these are the phases that I am going to cover up during today's session. So when talking about data gathering, there are two types of data gathering that could be done. For an example, custom, we can actually train custom data. We can actually gather custom data sets, or we can have data sets from the Vertex AI data sets, basically the managed data sets. And the development can be done on the Vertex AI workbenches, or we can use our own third-party development tool as maybe your own favorite ID, or you can use any other development tool as well. So for training, there are two options that are available, basically the custom training and the AutoML training. So when it comes to custom training, there are several predefined models available, and you can use those as well. And if you want, you can use your own machine learning models that are available. Also, you can use AutoML, as I explained earlier. For deployment, you can basically use the predefined ML runtime. So you can make your own containers as well. And you can expose that to a public endpoint. So basically, this is where you expose your public URL, public API of your machine learning model. And finally, we have the RESTful API that's coming from the public endpoint, or we can use the Python SDK to get the required results. Yeah, so I think that's pretty much everything when it comes to the workflow that I'll be covering during today's session. Yeah, so let's talk about different types of data sets that are available on Vertex AI. So one of the data sets is managed data sets, and we have the custom data sets as well. It supports both of the data sets types. So when talking about managed data sets, it's fully serverless. So we don't have to worry about where we're going to store the data sets and managing all the data sets, and how we're going to set up the pipelines, and how we're going to keep it updated. You don't have to worry about anything, because it's fully managed. You just have to pick the type of data set that you're planning to have, and it's a matter of maintaining it through the platform itself. And it's free to store, and it provides AutoML support as well. You can actually generate automated ML models out of the datasets that are available. And when talking about custom datasets, you can store the custom datasets in any location where you want. You can even store it in cloud storage on Google, or you can store on BigQuery, or you can use Amazon S3 as well, or maybe you can store it in another location on the internet as well. So maybe you can access the dataset via a HTTP request or a FTP access. So it's up to you. Yeah, so I'll show you, I'll actually go through the dashboard that's provided by Vertex AI. I'll show you how it looks like. Yeah, so basically the Vertex AI dashboard looks like this. And there's a section called datasets, where you can create new datasets and where you can import datasets. So the option is given here. You can create your own dataset, and you can view your existing datasets. And the management is made easy with a lot of dataset management tools given. So this is actually a sample dataset that I uploaded with the names of flowers and the pictures. So there are 3,667 items that are available. So these are actually used to label different flowers that's provided by a machine learning model. So I'll talk about that in the demonstration. All right. So there could be different types of data sets that could be stored on Vertex AI. So for an example, you can store images, as I shown previously. You can store tabular information, like numerical information. You can store for regressions and classifications, or you can store text-related information as well. So this is mainly for NLP related tasks. You can use it for single label classification, entity extraction, or you can do sentimental analysis as well. So finally, we have the type of video. So it also provides you analysis for videos as well. So basically, we can use it for action recognition, video classification, and object tracking. So these are the main types of datasets that are supported by Vertex AI. Well, so when talking about the images type, so these are the four main types as I explained earlier. So you can classify images by single label, multi-label, or you can even do object detection, or you can do image segmentation as well. So depending on your requirement, you can choose whatever the model you would prefer to use. It's up to you. Also, when talking about the tabular formats, the tabular forms, there are two forms given currently. There are more forms as well coming in the future. So you can use these tabular data for regressions and forecasting. So when it comes to regressions, you can conduct regressions such as logistic, linear, and clusterings. So these are all available for your AutoML task. So when talking about the text analysis, you can see it does text classification, text based on single label, multi-label, and it does text entity extraction as well. And finally, it does sentiment analysis. So these are the main features that's offered for text-related data sets. So when talking about videos, so these are the main features that is provided. For an example, video action recognition, classification, and video object tracking. So I'll show you how it looks like once again on the platform itself. Yeah. So if I click on create, you can see all the data types are given here. So if I want to import a data set of images, it's just a matter of clicking on the image classification model, and I can just give it a name. Let's say flowers 2. You can click create. So once I click on create, it starts creating the data. It starts creating the default data set, and I can import the data by using a CSV file or using BigQuery or one of the methods I mentioned earlier. So you can even upload your own data set, or you can browse through a cloud storage. If you have a cloud storage bucket, you can basically import any data set by using a cloud storage bucket as well. So if you have a cloud storage URL, so I already have a sample data cloud storage URL. So once I give the URL, I can simply import that into my data set. Yeah. So importing process takes some time. So maybe it would take around 20 to 30 minutes. So you can just leave it like that. And once the importing is done, you will receive an email, and all the images will be processed over here. And I'll show you how to develop the AutoML model as well. All right. So that's all about the data sets. I think I covered pretty much everything. I'll at the end of the presentation, I'll go back to that once again as well. So when talking about the notebooks, there are several features offered. There are two main types of notebooks available on Vertex AI. One of the notebooks is the managed notebooks. So basically, it comes with a pre-configured setup, based on the initial configuration that you're going to do, and it's fully Google managed, and it has JupyterLab installed on the default basis. And when talking about user managed notebooks, it's actually highly customizable, and you have the terminal access. You can it's fully user managed. You can do any customizations whatever you want, and you can even install your favorite frameworks and any other custom frameworks that you're using to do for use for machine learning. And it's up to you to install anything, because you are getting the terminal access and you're getting the root access. So it acts more like a dedicated VA. So whatever you can do, whatever you want, because it has all the you have all root access. So it has a pre-built VM, and yeah, so that's how it looks like. So when talking more about managed notebooks, so managed notebook instances are pre-packaged with JupyterLab and have a pre-installed suite of deep learning packages, including support for TensorFlow and PyTorch frameworks. And managed notebooks instances support GPU accelerators and ability to sync with a GitHub repository. So if you're doing any sort of a deep learning project, you might need graphic cards, and you might need a huge graphic card requirement, right? So with Vertex AI, you can basically eliminate that issue, and with the managed workbook, you can basically create a managed workbook in the platform, and it provides you all the GPUs and whatever requirement you want, and it's actually a easy way of configuring a dedicated notebook. And also it supports the Google Cloud authentication. So if you are trying to deploy any models directly to Google Cloud, you can execute all the Google Cloud commands on the notebook itself, and you can directly Dockerize all your testing containers, and you can upload it to the Google Cloud, the container registry. So likewise, when talking about the user managed notebooks, so basically it allows you to create your own virtual machine. So you get all the full access of managing your notebook, and you can install whatever packages you want. And it also supports TensorFlow, PyTorch, and it has two configurations such as CPU only and GPU enabled instances. So all these functionalities are given on user managed and managed notebooks. So I'll actually show you how to set up a notebook on Vertex AI. So in Vertex AI, you have the section called Workbench. So in Workbench, it allows you to create a new workbook. So you can see the managed workbooks are given over here, and you have user managed notebooks as well. Yeah. So in managed notebooks, you can actually click on create new notebook, and you can give it a name, and you can give it all the requirements, and you can actually configure your machine type as well. So if I give it standard machine, it will provide you 3 GB of RAM and one vCPU, and you can pick whatever machine you want. Also, if you want GPU support, you can add that as well. So since it takes some time to create a notebook, I'm going to move forward with the user managed notebooks as well. All right. So let's say if I want to create a custom notebook, it's just a matter of clicking on new notebook, and it shows you all the available options. So it gives you options such as Python 3, CUDA with CUDA support, and TensorFlow, PyTorch, R, and there are multiple other options. So you can actually choose whatever option you want. If you want to create a notebook with or without GPUs, that's possible. So I'll create a new notebook and show you how to create a new notebook. So you can choose whatever the TensorFlow version you want to use. So I'm creating one without GPUs. Well, so you can give it a name over here. So it's actually a TensorFlow notebook I'm creating, and you can customize the machine by clicking on the advanced options. And as you can see, all the machine configurations are given. Also, when compared to the managed notebooks, you will be given access to the networking section. So basically, you can even set up your own private or public IP. You can assign a static IP to your own notebook, and all security roles are given. So basically, it's more like a virtual machine for scientific IPython and all. All right. So currently, I already have a notebook created. So I'm going to show you how it looks like. So as you can see, it says demo TensorFlow notebook. So I'll just click on it. You can see it provides you access to Jupyter Lab notebook, and you can basically you can actually have Python R. It supports Python R and all. You can actually install whatever packages you want with the terminal they have provided. Yeah, so that's how it looks like. You can even customize the interfaces. So yeah, so that's all about the Workbench notebooks. I'll come back to that later on once we're having the demonstration. Yeah, so when talking about the ML libraries that are available, so Vertex AI supports almost all the libraries, ranging from PyTorch, TensorFlow, R, NVIDIA CUDA. So these are some of the libraries that are available, but you can do whatever customizations you want, and you can install whatever packages you expect. So there's no restriction at all because you get the full access. So these are some of the libraries that I can show that would support. Well, so when talking about training of models, Vertex AI training offers fully managed training services. Um, so basically, it supports AutoML training and custom training and hyperparameter tuning jobs. So these are some of the services that are available when it comes to training. Right. So when talking about training, when talking about AutoML training, these are some of the services that are provided. For an example, translation, speech to text. So you can do any task with the minimal code and the low code with low code. So basically, these are some of the functionalities that are available when it comes to AutoML. And when talking about the custom ML models, you can build your custom ML models with TensorFlow, Scikit-learn, PyTorch, or you can even use R as well. And it provides you pre-built containers when you're training your models. So for hyperparameter tuning jobs, basically hyperparameter tuning is choice of optimal hyperparameters for learning, and it's actually model argument where you can set before the learning process begins. Basically, over the time, you can identify which parameters are affecting for the maximal for your model and all. So basically, it's process of identifying all the parameters that are required. So you can even schedule hyperparameter tuning jobs on Vertex AI. Yeah. So when talking about the deployment phase, as I mentioned, I think I mentioned about earlier as well. It allows you to create endpoints. Basically, an endpoint is a feature that you can expose your machine learning model to the public, and you can actually call the endpoint by the backend, and you can retrieve the prediction from the backend itself. All right. So before a model can be used to serve online for predictions, it must be deployed to endpoint. So deploying model associates physical resources with the model, allowing it to serve online predictions with low latency. Batch predictions, which do not have the same low latency requirements, can be served with an undeployed model. So in Vertex, there's this feature called batch predictions. So if you want to get the predictions without serving it to public, you can even call the backend the batch predictions feature. And, you can just call it internally within the service itself. You can even deploy multiple models to endpoint and single model to multiple endpoints. So whatever the way you are comfortable with, you can basically call it. you can even have multiple endpoints for a single model, or you can even have multiple models for a single endpoint as well. So whatever way you want it to be, you can just simply configure it as you want. So this is how sample API request looks like. As you can see, this basically a curl request that can be sent to the AI platform. So you have to send the authorization token, and it sends you to it sends the data to the URL itself, and you can add all the data here. So once you call this endpoint, you get the prediction from the endpoint you have exposed to, and it's just a matter of passing all the required data. We have to have the correct values here, and I'll show that at the end of the presentation. So when talking about the Python SDK, so if you have a hosted endpoint, you can actually call the Python SDK to retrieve the results basically. So it's more like a client-side SDK where you can integrate with your backends to easily uh, call for the predictions from the endpoint, and you can display it over here. So as you can see, these are the values that I'm passing to the endpoint, basically the input values, and the output is predicted from the endpoint itself, and it's displayed over here. Yeah. So in addition to all the features I mentioned during my presentation, um, Vertex AI provides explainable AI solutions. Like explainable AI, I think most of you have heard about explainable AI that provides you feature attributions, example-based explanations, and model analysis. So it provides you comprehensive and highly dynamic explainable AI responses for your machine learning models. I'll show that as well. For classification and regression tasks, Vertex Explainable AI helps you to understand your model's outputs. So Vertex AI calculates how much each data feature contributed to the predicted outcome. So this information can be used to confirm that the model is behaving as expected. Also, you can identify bias in your models and generate ideas for how you can improve the models and the training data. So these are some of the types of data that we can use to generate explainable AI under the Vertex AI platform. Yeah, so as you can see in these examples, you can see this is actually image recognition example that's given to recognize whether it's a cat or a dog. You can see some of the features of the cat has been highlighted. So that's been done by the model itself. And you can actually use these for debugging purposes for your models. If you're not so sure about how it works and all, you can actually use these for debugging purposes. And mainly the feature attributions can help to detect issues in the data that standard model evaluation techniques would usually miss. Basically, this is mainly for debugging purposes, and you can easily evaluate your ML models with explainable AI. We're talking about all these examples. It's actually from the official website. You can refer to the official website and see the main examples as well. All right, so let's get into a practical coding session. I'm going to show you one example from AutoML and another example from custom ML model. So let's get started. All right, so first of all, I'm going to show you how we can set up a workbench. So I think I already shown how to set up a managed workbench, and from this you can actually start a TensorFlow workbench without GPUs. So I'm going to create a new notebook without GPUs. So I'm going to give it a name called TensorFlow 2.9. So we can use the default name itself. And from the advanced options, we can basically set up the machine type. So it's at N1 standard 4, and I'm going to change it to N1 standard 1. And it gives you the monthly estimate as well, the monthly cost. And I'm going to give it in SAN2 machine. All right. So I'm going to create the machine right now. And it might take some time. So because of that, I'm going to use my existing machine. All right. So I already have a machine provisioned over here. So I'm going to use the Jupyter Lab notebook, which is given by their own service. Yeah, so in the code lab they have given, there's an example of doing a small prediction with TensorFlow. So basically, this is the code lab that I'm going to follow during this demonstration. It's actually a full consumption prediction model that's built with TensorFlow. It's actually a full custom model. So I'm going to show you how we can deploy the custom model on Vertex AI. Yeah. So this is the model that's given on TensorFlow. This is basically the example they have given. It's actually a basic regression for predict fold efficiency. And yeah. All right. So I'll go to my Workbench. And I'm going to delete my existing file because I don't need it anymore. All right, so I'm going to create a new folder called MPH because I'm going to do it from the beginning itself. So you can create a name, and you can have two subfolders as well. You can have multiple subfolders. So I'm going to make a new Python, the subfolder for a new Python package. So I'm going to call it trainer. And again, I'm going to create a Python file inside that. You can click on new file and give a name called train.py. And that's going to be my Python file. So in the parent directory, I'm going to create a Docker file because I'm going to containerize this ML module. Yeah, so this is my Docker file, and this is my Python file. So from the code lab, you can get the training code from the code lab session. So this is basically taken the exact example from TensorFlow. So I'm going to just copy and paste the entire thing. All right, so I just copied the training code from the code lab, and we might have to do some changes because we had to change the directory, the output directory of the model itself. So we can set up our bucket, the cloud storage bucket name from here. So before that, there are a few more steps to be completed. I'll quickly go through that. Yeah. So I'll open up a terminal. And there are a few more steps to be completed. So first of all, I'm going to set up all the environment variables that are needed. So before that, we had to find out the project ID. So from this command, you can actually find your project ID. This is my project ID. And you can set up the environment variables as given. So first of all, we have to set up an environment variable called project ID. And I'm going to set up another environment variable for my bucket. Yeah. So this is my bucket, the cloud bucket is going to be. And if I print it once again, I should be able to see the full name. Yeah. This is how it looks like. So the next step would be creating a new cloud storage. So I'm going to do a small change because I already have bucket with the same name itself. So I'm going to call it bucket1. So then I'm going to create a new cloud storage bucket. So I can actually use the same command line to create the Google Cloud Storage bucket because it actually gives you access to the Google Cloud console. So I can just create a bucket from the terminal itself. Yeah, so you can see the bucket has been created. So if I go to cloud storage, you should be able to see the bucket that I just created. Yeah, this is the one. So now what I should do is I already have the bucket URL, so I can just paste it in the environment variable that's given in the train.py. So basically, we have to replace the bucket name because this is going to be the model output file. This way, we are going to store the artifacts, the output artifacts of the model. So we can just replace it with the bucket name. So as you can see, as I mentioned, this actually uses a custom data set from Kaggle. So this is loaded by external third-party URL. So there's no restriction such as you have to stick to the Vertex AI itself. You can even have third-party sources for loading data sets. So this is actually loaded by third-party URL. So now the bucket URL has been set, and you can see at the end of the code, it automatically saves the model into the bucket we have given. So the next step would be creating the Docker file, because we are going to make a Docker image, and then we are going to push it to the container registry, and finally we are going to deploy it in Vertex AI platform. So I'm going to create my Docker file. So basically, I'm going to use a pre-built container, a deep learning container, deep learning platform. CPU 2. So basically, this is the TensorFlow version, and I'm going to use CPU, and it's going to be run with TensorFlow 2. So that's going to be the container, the parent container that I'm going to have. And I'm going to set my work directory also. And I'm going to copy my trainer file. And finally, I'm going to set the entry point. Basically, I'm going to run the train.py Python file as the entry point. Yeah. So you can see it automatically sets the train.train module, and it's going to inherit from the parent container, basically the deep learning platform container. And yeah, let's try to run the Docker build command to make it a container. So before that, I'll set another environment variable. I'll set this. Basically, we can add this image URL, and I'm going to give it a version. I'm going to call it version 4 because I already have another version available. So I'm going to call it version 4. Yeah, as you can see, this is the content image. These are the content image going to be stored. And finally, I'm going to run the Docker build command. So I have to navigate to my directory, and then I'm going to run the Docker build command. All right, so as you can see, the image has been built, And if I go to Docker images, I should be able to see my image. So this is my image, which is under the tag v4. So I'm going to run my image and see what it produces. So it should start training the model under the container itself. Let's see what it produces. Yeah, so as you can see, it started the training phase, and you can see it trains all the ports. And I'm going to just stop it because it's not the point here. I'm going to deploy this container into the container registry, and then I'm going to import it towards the Vertex AI platform. So finally, I'm going to push my container into the container registry. So I can use the Docker push command, and I can give my image URL as well. Yeah, so as you can see, it's already pushed, and the version has been pushed as well. So if I go to the container registry, you should be able to see my latest version. Yeah, so this is the version. So basically, which is known as v4. Then the next step is going to be the deployment phase. So basically, I'm going to start training. So you should go to the training section, and you can click on create. So under the training, there are few options given, which is called training pipelines, custom jobs, and hyperparameter training. So from these three options, you can go to custom jobs, and you can click on create. So from the dataset, you can just click on no manage dataset because we are using a custom dataset. So because of that, I'm going to click on no manage dataset, and I can click on continue. And I'm going to give it a name. Let's say workshop demo 1. We can give a name and description as well. And from the advanced section, if there's any security keys, you can set that as well. I'm not going to set anything. Yeah, so in the training container, this is the most important section. So we are not going to use any pre-built containers. So we are going to use our own container. So because of that, I'm going to click on custom container, and we can choose our container from here. And I'm going to choose the v4. So the model output directory has to be this. This way we are going to store the model related information. So I'm going to get my storage bucket URL once again. Bucket name, and then my path is going to be my export path is going to be /mpg because that's where I'm going to store the model. All right, so yeah, I think I said that. And if you're planning to do any hyperparameter testing, you can enable that as well. So since I'm not going to do it right now in this demonstration, I'm not going to open it. I'm not going to enable it. All right, so I can click on continue, and you can choose your region. So it's in my default region, and you can even choose a machine type. So I'm going to give it a standard machine type because I don't need any high performance machines. So I can just use a normal machine, standard machine. So I'm going to give it the first one itself. So the accelerator type, I don't have to pick that because if you're using a GPUs and all, if it's a deep learning project, you can give a GPU as well. For this demo, I don't need any GPUs, so I'm just leaving it blank. And node worker pools I don't need to set, and can just click on continue. Yeah. So for the prediction container, there are few more options. So we have already configured the training container. So the training container, we are going to use a custom container for the training container, custom image for the training container. For the prediction container, we don't need to use a custom container because it's actually developed with the TensorFlow. So we can choose the framework. So I'm going to choose the pre-built container framework, and from here we can choose TensorFlow and the version. I'm going to give it 2.8. I don't need any acceleration, and yeah, so I can click on start training. Yeah, so I'm going to refresh it once again. So as you can see, it's scheduled, and it says it's in the status of pending, and you should be able to view all the logs from here. So as you can see, it's still under the pending mode. So it takes some time. It takes like 5-10 minutes. So you have to wait until that completes. So I'm not going to continue with that because I already have a trained model under the same data set. I'm going to show you the demonstration from my trained model itself. So as you can see, this is my trained model, and all the statistics are given here. And even if you can see all the logs, the content logs, the training logs. Yeah, so this is how it shows all the content logs. The trainings and everything has been completed over here. All right, the final phase is going to be deploying an endpoint. So I mentioned that you have to have an endpoint to deploy it into a public interface. So for that purpose, you can still click on the train model. So basically, this is my training custom job. Once the model is trained fully, you can go to the model section. So under the model section, you can go to the train model. And this is my train model. And you can click on deploy to endpoint. Yeah, so from here you can give it endpoint name. So you can give it like test endpoint 1. And you can give the setting. If you're planning to make it public, you can give it standard, or if you're planning to make it private, you can keep it as a private endpoint. So I'm going to click on continue. And traffic split, basically this mainly for load balancing. I'm going to give it 100%, and machine type is going to be standard. Yeah, so you can give it the node count as well. So this is actually applicable for charging. If you're trying to deploy into multiple nodes, trying to have multiple nodes for scaling and all, you can give it here as well. So I'm going to leave it as 1, and I'll continue. And finally, you can enable model monitoring as well, but I'm not going to enable it right now. So if you're planning to do any monitoring, you can do that as well. You can enable this, and you can get the statistics. So finally, once you're done with all the configurations, you can click on deploy, and you can see the deployed endpoints will be available over here under the endpoints. So you can see the endpoint is being deployed. So that also takes some time because we have to wait until the model is fully trained. So since it takes some time, I'm going to continue with my existing model. So I already have 2 models trained over here. So I'm going to continue with my full model, the previous model endpoint that I made. Yeah. Okay. So under the endpoint, you can see there's a section called sample request. So from here, you can you can generate the curl request, or you can even use the Python SDK to communicate with the endpoint itself. So if you're planning to communicate with the RESTful API, you can use a tool called, you can use tools such as Postman or something to test the endpoint. So I'm going to test the endpoint right now. So for that, you need the authentication key. So you can run this command to get the authentication token. Yeah, so this is my access token. So I'm going to copy and paste it. So these are my input data, and I'm going to send the request. So as you can see, this provided me the expected output, and the prediction has been given. And these are the input parameters, and the prediction is given, and you can see the model name as well. So you can call this API call from your backend, and you can simply integrate with your existing applications. So that's about the RESTful API. So also there's another option where you can call this endpoint from the client side. So they have this Python SDK. So I'm going to show how to work with the Python SDK as well. Yeah, so in the Colab, they have given the code for the Python SDK. So I'm going to create a new file. Called training.testing.py, and I'm going to copy the code. Yeah, so you can enter project number here, and your endpoint ID also here. So you can find your project number under this. So basically the project number, yeah, you can find the project ID from here. And you can replace your endpoint ID as well. Yeah, so once you do that, you can try running this file and see. So I'm going to run my testing file. Yeah, so simple as that. You can see the API response is given from the SDK itself. So the input values are here, and the endpoint names are given here. So that's how you get the outputs with the Python SDK. So yeah, so I'll quickly show another demo. It's about the AutoML. So I think I covered the custom ML part. If there's any questions, let me know in the comments. I would like to address the questions as well. So meanwhile, I'll try to address the AutoML phase as well. All right. So in Vertex AI, you can, so as I mentioned, you can import multiple datasets. So this is a dataset that I imported earlier, the flowers dataset. So you can see there are 3,000 contents available, and you can just simply go inside the dataset. And in here you can see there's an option called train new model. So I import this dataset under the category of image labeling. So from here itself you can create a new labeling model. So you can click on this, and the model type is going to be AutoML, and click on continue, and you can give it a name. Yeah, so Budget as in, so you have to refer to the pricing guide. They have given multiple pricing options for different types of trainings. So if you're planning to train it for multiple hours, node hours, you can just give estimate. So for this model, I'm going to give it budget of 1 or 8. I'll just give it. It has to be minimum. Yeah, so I can start training. So you can see if I go to the models, you can see um, so this is the earlier model that I have deployed, and the training is already being happened, so that's why it's not here. So I'll show you how to get the outputs from the already trained model. So I'm going to go inside the flowers model. This is the one I have already deployed. So from here, can go to the version, and so there's a section called deploy and test. So in the evaluate section, you can see all the explainable AI related components and all the precisions and recalls and all the statistical data, which is going to be useful for your predictions and model improvements. So if you go to deploy and test, you should be able to upload a new image from here. So I'm going to download image of a sunflower. And, let's see if it detects a sunflower. So I'm going to upload image from my download. It's uploading, and you can see the results are given. It's fully detected as a sunflower, and all statistics are given here. So yeah, that's how it works. Simple as that. You can make AutoML models with no code at all. And if you're planning to deploy custom ML models, also you can do that as well with Vertex AI. Yeah, so that's all about it. Um, thank you very much. So I'm open for questions. I'm willing to answer.
All right, so it's time to wind up an incredible event, Collab to Cloud with Google Vertex AI. So, big thank to our speaker Suresh Piris, who is a co-founder of InfoWaves, a GDG organizer and a cloud researcher. Thank you once again, Suresh, for joining with us. Also, big thank to all of the participants who joined with us today. And you can drop your questions to Suresh and clarify your doubts on Google Vertex AI. So I believe we can wind up the session. All right. So let's wind up Google Developer Group Sri Lanka Cloud Tech Talks June edition. Stay safe and have a great day.